When replacing a kitchen above sink fluorescent under cabinet fixture with an incandescent fixture where space is limited, consider a pancake junction box, also known as a PJ box. A pancake junction box is a low-profile box designed to fit in tight spaces. It mounts directly to the cabinet or paneling, providing a surface for mounting the fixture. Another option is a ceiling joist box. This is a shallow box that can be mounted to the ceiling joist above the cabinet. It allows the fixture to be recessed into the ceiling for a cleaner, more integrated look. When replacing a bathroom above sink fluorescent wall-mounted fixture with an incandescent fixture and the existing cable is near a stud, consider a mounting bracket with an adjustable extension arm. Some fixture mounting brackets include adjustable extension arms which allow you to mount the fixture offset from the stud without cutting into it. Another option is a flush mount box with a side wall mount. This type of box mounts flush with the wallboard, but has a side wall mount allowing you to attach the fixture to the non-bearing stud without needing to cut into it. Firstly, when working with existing wiring, always use a fish tape or wire puller to carefully retrieve the non-metallic cable from the existing hole or slot. Secondly, keep the wires short and neatly coiled to minimize space constraints within the electrical box. Thirdly, securely fasten the outlet boxes using appropriate screws or nails, ensuring a stable and safe installation. Fourthly, make sure all electrical connections are properly completed and that any exposed wires are insulated with wire nuts and electrical tape. This minimizes the risk of electrical hazards. Fifthly, when dealing with limited space, consider using a low wattage incandescent fixture to reduce heat build-up within the enclosure. Understanding National Electrical Code, or NEC, requirements is critical for safe and compliant electrical work. Article 314 covers outlet boxes, conduit bodies, and handhole enclosures. It provides detailed specifications for box sizing, conductor fill, and the number of conductors allowed in a box. The NEC specifies the minimum dimensions for boxes based on the number and size of conductors entering the box. Using the correct size box is important to prevent overcrowding, which can lead to overheating and potential fire hazards. The NEC also addresses box fill calculations, which determine the maximum number of conductors, devices, and fittings allowed in a box. These calculations are based on the volume of the box and the volume occupied by each conductor, device, and fitting. The NEC provides tables and formulas to assist in performing these calculations accurately. When installing electrical boxes, the NEC requires that they be securely mounted and supported. This ensures that the box remains in place and that the connections within the box are protected from strain. The NEC also specifies the types of materials that can be used for electrical boxes, depending on the application and environment. Metal boxes are commonly used in commercial and industrial settings, while non-metallic boxes are often used in residential applications. The NEC provides guidelines for grounding and bonding electrical boxes to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC also addresses the installation of electrical boxes in wet or damp locations. Boxes used in these locations must be weatherproof or rated for wet locations to prevent moisture from entering the box and causing corrosion or electrical hazards. When selecting an electrical box, it is important to consider the type of wiring method being used. The NEC specifies the types of boxes that can be used with different wiring methods such as non-metallic cable, rigid metal conduit, and electrical metallic tubing. The NEC also addresses the use of cable clamps and connectors to secure cables and conduits to electrical boxes. These fittings must be properly installed to ensure that the cables and conduits are securely held in place and that the connections within the box are protected from strain. The NEC provides guidelines for the installation of electrical boxes in fire-rated walls and ceilings. Boxes used in these applications must be fire-rated to prevent the spread of fire and smoke through the wall or ceiling. When working with electrical boxes, it is important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and working with de-energized circuits whenever possible. It is also important to be aware of the potential hazards associated with electricity, such as electric shock and arc flash, and to take steps to minimize these risks. When installing electrical boxes, it is important to ensure that they are properly aligned and level. This will make it easier to install devices and fixtures in the box and will also improve the appearance of the finished installation. The NEC requires that electrical boxes be accessible for inspection and maintenance. This means that the box must be located in a place where it can be easily reached and that the cover of the box can be removed without damaging the surrounding materials. When working with electrical boxes, it is important to be familiar with the different types of tools and equipment that are used in electrical work. This includes wire strippers, pliers, screwdrivers, and voltage testers. It is also important to know how to use these tools safely and effectively. The NEC provides guidelines for the use of electrical boxes in hazardous locations. Boxes used in these locations must be specifically designed and rated for use in hazardous environments to prevent explosions and other hazards. When installing electrical boxes, it is important to ensure that they are properly supported. This may involve using box supports, mounting brackets, or other hardware to secure the box to the wall, ceiling, or other structure. The NEC requires that electrical boxes be installed in a neat and workmanlike manner. This means that the boxes should be properly aligned, securely mounted, and free from damage. The wiring within the box should be neatly arranged and properly connected. When working with electrical boxes, it is important to be aware of the potential for corrosion. Corrosion can damage the box and the connections within the box, leading to electrical problems. To prevent corrosion, it is important to use boxes that are made of corrosion-resistant materials and to protect the boxes from moisture and other corrosive substances. The NEC provides guidelines for the installation of electrical boxes in concrete. Boxes used in concrete must be specifically designed for use in concrete and must be properly installed to prevent damage to the box and the concrete. When working with electrical boxes, it is important to be aware of the potential for electromagnetic interference, or EMI. EMI can interfere with the operation of electronic equipment and can cause problems with electrical systems. To minimize EMI, it is important to use shielded boxes and to properly ground the boxes. The NEC provides guidelines for the installation of electrical boxes in manufactured homes. Boxes used in manufactured homes must be specifically designed for use in manufactured homes and must be properly installed to ensure safety. When working with electrical boxes, it is important to be aware of the potential for static electricity. Static electricity can damage electronic equipment and can cause problems with electrical systems. To minimize static electricity, it is important to use static dissipative boxes and to properly ground the boxes. The NEC provides guidelines for the installation of electrical boxes in swimming pools. Boxes used in swimming pools must be specifically designed for use in swimming pools and must be properly installed to ensure safety. When working with electrical boxes, it is important to be aware of the potential for water damage. Water damage can damage the box and the connections within the box, leading to electrical problems. To prevent water damage, it is important to use waterproof boxes and to properly seal the boxes. The NEC provides guidelines for the installation of electrical boxes in healthcare facilities. Boxes used in healthcare facilities must be specifically designed for use in healthcare facilities and must be properly installed to ensure safety. When working with electrical boxes, it is important to be aware of the potential for vandalism. Vandalism can damage the box and the connections within the box, leading to electrical problems. To prevent vandalism, it is important to use tamper-resistant boxes and to properly secure the boxes. The NEC provides guidelines for the installation of electrical boxes in schools. Boxes used in schools must be specifically designed for use in schools and must be properly installed to ensure safety. When working with electrical boxes, it is important to be aware of the potential for fire. Fire can damage the box and the connections within the box, leading to electrical problems. To prevent fire, it is important to use fire-rated boxes and to properly install the boxes. If the stud is non-bearing, you may be able to carefully notch the stud to accommodate a standard box, but consult with a qualified professional to ensure structural integrity is not compromised. The depth of the notch should be minimized. If using a pancake box, be sure it's rated for the intended use and provides sufficient space for wire connections. Always consult local electrical codes and regulations for specific requirements in North Carolina. Using the right tools such as wire strippers, pliers, screwdrivers, and a voltage tester ensures the job is done safely and efficiently. Remember, safety is paramount when working with electricity. If you are not comfortable performing the work yourself, hire a qualified electrician. Consider using a smaller wattage incandescent fixture to reduce heat build-up in the tight space above the sink. This is important for safety and longevity of the fixture. Always disconnect the power supply before starting any electrical work. This prevents electrical shock and ensures a safe working environment. Double-check all connections to ensure they are tight and secure. Loose connections can cause overheating and potential fire hazards. Use wire connectors that are appropriate for the size and type of wires being connected. This ensures a reliable and safe connection. When working with non-metallic cable, be sure to protect it from damage. Avoid sharp bends and secure it properly to prevent strain on the connections. If you are unsure about any aspect of the installation, consult with a qualified electrician. They can provide guidance and ensure the work is done safely and in accordance with local codes. Before starting any electrical work, obtain the necessary permits from your local building department. This ensures that the work is inspected and meets all applicable safety standards. Document the work you have done, including the type of boxes used, the wiring connections, and any other relevant information. This will be helpful for future maintenance and repairs. When replacing a fixture, consider upgrading to an energy-efficient LED fixture. LED fixtures use less energy and last longer than incandescent fixtures. Check the voltage rating of the new fixture to ensure it is compatible with the existing wiring. Using a fixture with the wrong voltage rating can damage the fixture and create a safety hazard. Make sure the fixture is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Use a level to ensure the fixture is installed straight and level. This will improve the appearance of the installation. After completing the installation, test the fixture to ensure it is working properly. If the fixture does not work, check the wiring connections and the circuit breaker. Consider using a dimmer switch to control the brightness of the fixture. This can save energy and extend the life of the bulb. When installing a dimmer switch, be sure to use one that is compatible with the type of fixture being used. Some dimmer switches are not compatible with LED fixtures. If you are installing a new circuit, be sure to use the correct size wire and circuit breaker. Using the wrong size wire or circuit breaker can create a safety hazard. Protect the wiring from physical damage. Use conduit or other protective measures to protect the wiring from nails, screws, and other objects. Keep the wiring away from sources of heat and moisture. Heat and moisture can damage the wiring and create a safety hazard. Inspect the wiring regularly for damage. Replace any damaged wiring immediately. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary safety precautions. When working with electrical boxes, it is important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and injuries. To minimize the risk of arc flash, it is important to wear appropriate personal protective equipment, such as arc-rated clothing and face shields. It is also important to work with energized circuits whenever possible. When installing electrical boxes, it is important to consider the aesthetic appearance of the installation. Choose boxes that are the right size and shape for the application and that blend in with the surrounding decor. Be sure the replacement fixture is compatible and is rated for the location in the kitchen or bathroom, and make sure to inspect it prior to installation for any damage to the fixture.